triangular element and can be expanded by adding two members and a joint. So these are the common of trusses nga to encounter, but they are not limited only to this. We can create our own truss. This is an assembly of truss. It's 3D, but in analysis we can only take one representative of this. So this one is a typical truss that we encounter in most of the situation. So there are only two types of trusses: the determinate truss and the indeterminate truss. Yung unsa man ang determinate truss o indeterminate truss. Mag-una ta sa determinate truss. So ingani lang, no? 2D truss is just simple truss. Determinate truss is a simple truss. Okay, when it is simple truss, it's just 2D or planar truss. It could be a representative only of the other, but of the, just like this one here, repeated guy, you know. You take only one truss, then you can, that is doable, no? You can have like this. And then this is how the simple truss look like. It's supported on a roller on the other side and pin on the other side, and the joints are pin connected. But seldom but this is seldom seen in the actual. But there's nobody will stop you if you do it. But usually what is being done is like this. So welded siya, or it could be bolted, and the connection should be made rigid. This one, the failure of this is just the connection. Why? Imo pa siyang gibangagan, so naluya na. So ini siya noon, ang iyang joint is gidugagan, so di sa mo tutulikon ang iyang joint, no? So who likes nga ligon ang imong mga tuhod, no? Atong tuhod is a typical pin connected. Why? Because we can rotate, no, about the joint. But something also special on our knee is that ang bukog nga doon sa joint, nidako dito siya. Dili siya uniform ang iyang position dito. So pag abot sa joint mo, nidako siya. So meaning nga ni gyud gyapon ang iyang figure, nga medyo dugangan siya o area. Okay, not like this, no? Nga wala gyud dako, no, gibangagan pa noon. Ang atong bone is anam siya dako, antod nga dako siya sa joint. So up siya tanawon, ingon ani siya na siya expansion. Okay. So ours is been connected just like this. Okay, and it can be solved using equilibrium only, no? Summation of forces is already enough to solve this, the internal forces. How about the indeterminate truss? Mauni siya ni Piniso sa dito. It is a complex truss, 3D truss, space truss. So kita ni mo ni siya nga 3D truss, complicated truss, space truss. So mo na siya. So can we do it by using equilibrium? No, cannot do it. You have to do equilibrium and compatibility. Now, these two are present in what we call finite element method and stiffness method. And it's not practical to solve it manually unless it's very simple. It's just the simplest of all. But this one is not simple. The degree of indeterminacy of this kind of structure is already 1,000, 10 of 1,000. So meaning that's the level of determinacy. Now, that's why it's not practical to solve it manually. The use of software is recommended. Okay, so you have to use software. Okay, so yeah, as a structural analyst, you should structural engineer, you should be also good in using software. Okay, so that's it, class. Okay, so method of solution for simple truss. Number 1, method of joints. Method of joints. So number 2, you have orthographical method. So the graphical method, but they're somewhat the same. Practical method of sections. Stiffness method. Okay, so these are the practical, no? So method of joints. Okay. Okay. So kini method of joints is kuan gid siya kanang unsa imong gi-describe method of joints siya, joint gid siya, no? Method of joints. You are going to uh, steps solve reactions or external sum of external forces. Is zero, including moment. So you have to solve reactions first. Number two, step one. Step two, solve internal member forces or internal, no? Member forces. Internal forces. So that's it. That's how you do method joints. Okay? Okay, so nakapalo pa mo class?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So we will have an example. Example. This one. We'll solve this. I will just convert this into what we call tawag na kilonewton, no? So I will copy this. Copy. Din na lang na pag-paste din. So, muon ko na siyang okay, so we will solve an example of method of joint. So we have example. Paste this. Okay. So we have here a class, no? Okay. So still have, I think, 15 minutes. Okay. So if we do, actually, if we try to understand, uh, forces are loaded at the joints. No? That is how class is. So it should be located at the joint. No? Okay. So so we have four loads here. So it's on the top chord applied is 10 kilonewton because it's P and P is equivalent to 10 kilonewton. While in the at joint D there is 2P, so this is 20. Now the dimension of the truss is 16 meters from span from A to E, 4 that's 16 meters. The total height is 6 meters. In other words, mauna siya ang length. So the the you can say that here that the horizontal length of its member or horizontal length L, or let us say LX, no? LX. Okay, the one that horizontal is 4 meters, and we have LY. Basically, like B to H and D to J is basically 3 meters, and also UY also is equals to 6 meters, like in the case of C to G. Okay, so diagonal length, I will just say LD, are like AH, HG, GJ, GE, HC, CG is equals to 5 meters. Okay, that's it, 5 meters. Because this triangle forms a 3, 4, 5 triangle, meaning 4 horizontal, 3 vertical, so the hypotenuse is square root of 25, which is 5. Okay. Now, using step 1, we can actually solve. I will insert here arrow shape. This one. There is a force here called reaction. Okay, I will change color for this color. Is the format of line. Color is black. And then the size. Where's the size? Okay. Mao na siya, doon na siya gitawag nga reaction A. Ang isa po dayon kung atong ibutang. Ano ako nila ni format? Ako ni. Kaya pangit akong ko. Ano? Format. Color black and the sizes. Okay, so I'm gonna 3. Okay. These are the reaction at A. So we call that RA. I'll copy this, copy and paste this. So on the other side, this is spin, so you can support vertical as well as horizontal. But I will, yeah, pwede ka ako ngani ang nalandaan. So that's the assumed direction. Okay, so if I am going to sum up forces x equals to 0, so I can the name of the force here. I will insert a text box here. I will call that as AY. AY. Okay. There's no fill. No fill. Oh. Is that no? Then on the other side, this is considered as so related. Walang A, B, C, D, E. E na siya, E. E. Record E, Y. And then on the other side, insert. On the other side, I will call this as EX. Okay. So, I'll sum up versus X equals to 0. Kung sa may tabo, sum up versus equals to 0. I have minus EX acting, EX. And then, there are no other horizontal forces. Can you see horizontal forces there? Exit EX. So, you see, there's none, so it's equal to 0. So that's why you can see that EX is 0. Okay. Now, if you sum up versus Y equals to 0, okay, ano lang natin siya, mag-insert ko kuan, mag-insert ko, insert ko, muna ni. Okay lang. Ayan lang. Okay, summation forces X equal to 0, Y equal to 0. So, you have to include also the external forces. No? There are two upward forces in terms of AY plus EY. So, no doubt they are positive because they are directed upward. Then, the sum of all vertical forces, no? I have minus P on the other side, minus P on H, minus P on G, and minus 2P. All of them are negative. So I think all the forces there are constant. Wala na may lain. Ang J, what my force is equal to 0. That means EY plus EY is equal to 5P. Okay. We do not know how unsaon na nila pagbahin ang 5P. Basta sila doon tag-iya. It's just like having doon na may 5 ka hektarya ng yuta. No? So, wala ano may baway kung unsa kadako ang yuta ni AY, unsa sa yuta kadako ang yuta ni EY. Basta ang sum sa among yuta is 5 hectares. So, 5P. We need to determine what is for EY. So, we still summation of moment. We do summation of moment, actually. Need to copy that. And I will say summation of moment. Moment. Now, moment, you should have a moment center, like for example, E. I will just put this into a subscript na lang. Subscript na siya. Moment about E must be equal to 0. So here you use counterclockwise CC positive and C negative. Okay, meaning counterclockwise positive and clockwise negative. Okay. We are talking about rotation, no? Because if a force is not passing through that point, it will cause a rotation. But if it pass on that moment center, it has no moment, so it has no rotation. So if our moment center is E here, so all of the forces here do not pass through this point. Okay, they rotate either in clockwise or counterclockwise. So we account all the rotation of forces and sum them equal to 0. So the first rotation is AY. So AY times the moment arm, which is 16 meters. That's the perpendicular distance of the line of action AY to point E. It is positive because it will, this is negative. Okay. Why? Because CC is plus and C clockwise is negative. And if you put your hand on your finger, index finger on point E, and try to imagine the rotation of AY, so it clearly rotates in a clockwise rotation. Then another positive is you have the P that acts on A, that acts on A. And then that's positive, but you have 16 there, still 16. In another P, positive again. This time, this P is nearer. That's only 12. The perpendicular distance is 12 meters. We put meters here. And then another plus P, we have 8 meters. And then we have minus 20, because that's 2P. 20. Let me just see P. 2P times 4. There's none. So 0. So you can solve EY there. EY equals to, it's sum all of them. So we have 16P, 16P plus 12 plus 8 minus 8, 28 divided by 16. So we have 1.75 P. Okay? Or that is equal to 17.5 kilonewton. Okay? And then we substitute AY to the first equation. We use this as equation 1. Equation 1. So to equal 1. So you have 17.5 EN plus EY is equal to 5G. So we have EY is equal to, well, 5 minus 1.25, that's 3.25 P, or that's equals to 32.5 kilonewton. So that's how we solve the reaction class. Okay. Now we are ready for step 2, but I think we don't have time anymore. So basically, this is what is our discussion for this morning. It's about trusses, and then what I have discussed is not very difficult. No? So what you did is just I just introduced to you what are trusses and then the method of introduction. So we will continue this next one, and then I'll just give you as assignment. Okay. So internal forces for the following loaded class. I'll just post this class. Okay, I'll read this and I'll post this so that you can find your assignment class. So okay, before we will go on, I'll just I'll stop sharing. Okay. So
Sir,
yeah.
ang katong sa equation 1 nimo sir ba, di ba positive 2p man nun ta to?
Sige lang, i-correct ko ni. Masig na kuha na to, na i-correct ko ni siya. No? Anyway, ang tinood nga answer mo, answer niya. No? Save to. Okay, so, muna siya. So, mag-post ko og duha ka structure, simple task. Inyo na siyang i-submit as assignment. No? So, that will be graded actually. Assignment has bearing on your grade. So, but not the same as quiz. So this is just for assignment for you to exercise. I will put two structures there, simple structures that we are going to solve so that I need to collect that next meeting. Okay, class? So I'll sign out now. So,
Sir, assignment 1, wala pa ka nag-post.
wala pa ko nag-post assignment 1.
Yes, sir.
Oh, okay. Okay, sige lang. So, kinina lang ato assignment 1.
Sige, sir. Salamat, sir.
Yes, sir.
Thank you, sir.
Yes, sir.